Good day and welcome to this video in this series teaching C#.NET for engineers. In this video we're going to look at an introduction to inheritance, part 1. Now, what is inheritance in object-oriented programming and why are we using it? If you go and ask this question to ChatGPT, the example it will give you is actually quite a good example. And that is, if you are writing a class, let's say you are doing some sort of a computer game, you're developing some sort of a computer game, and you need to have some animals walking around in the field that do certain things, and you need to animate them and make them make sounds, etc. Then maybe you will write in your C# project a class called animal, and you will give this class some properties or methods that says eat. If you tell the animal object to eat, it will move its head up and down, and if you say sleep, it will lie down, etc. Things like that. Now, let's say you want to create a different type of animal, one like a dog class. Now you can see that the dog, obviously being an animal, it also eats, it also sleeps, but it will also bark. Right? And so you can see there's a big overlap in this code. If I'm going to have an animal class and then I've got a separate dog class. And so what you can see is that this code highlighted here will have to be repeated for every new class of animal that you are going to create. So this violates the do not repeat yourself or so-called dry principle of programming that says you shouldn't duplicate code everywhere in your code base. You should try and reuse code as often as possible. So the way that you would do this in C# is to create, for example, your animal class, right? There's very abbreviated example here. So here I've got an animal class and I've got just one method called eat. And in this method, all I'm going to do is I'll write to the console, I'm eating. And then I've got another class, dog. And can you see the colon there? And then animal. That means that's the syntax in C# to say this class dog inherits from animal. And you can see there's a method called bark there, and which extends the animal class. It adds something on top of the animal class, but because it inherits from animal, it will also have an eat method in the dog class, right? So that is the syntax for inheriting ensuring that the dog class inherits from the animal class. So one of the key uses of inheritance is by extending what the base class does. So that's exactly what our previous example did. So for example, the dog class inherits from animal, and that means that effectively you could say it's almost as if the code for animal is embedded inside of the dog class, but you don't actually have to embed or repeat that code. By simply putting that colon there and saying I inherit from the animal class, you get all of the properties that are marked either as public or protected in the animal class, you get for free in the dog class, and you don't have to code it. So in other words, my dog class is simply going to look like this. And if I write another class called, for example, a cow class that also inherits from animal, it will also get these methods for free. It will be replicated effectively in this code without repeating it. And I can then have other methods in there such as moo or get milked, etc. So you can see this is a pattern where we take our base class and we extend it. In other words, we take the properties that are in our base class and the methods in our base class, and we add other methods on top of it in the inherited class. This is called extending. I'm extending the properties of the base class. Let's look at an engineering example. Let's say you've got some sort of a infrastructure network. It could be a road network or a rail network, and you have a class to represent one of these elements in your network. And let's say you are calling that a segment class. Now each segment has to have a from location and a to location. Those are our attributes or properties. Obviously it's going to have a length. That will be most likely a read-only property which will be calculated from the difference between the from and to location. You're going to have GPS coordinates at its start and GPS coordinates at its end, and maybe you have a whole set of GPS coordinates, one at every 10 meters, to give you the path of the segment in space, in two-dimensional space. So this is our segment class. Now, what happens if we want to use this example of a segment class in some sort of an application that we are writing to do some modeling or analysis of a road network? Well, now our segment is going to represent a road segment. So I can add on top of this now some properties or methods that apply specifically to road segments. So road segment may have something like a rut depth, it may have a roughness, it may have texture depth, etc. Right? So I could have, for example, a road segment class, and now I could go and add all of these methods below this segment class, right? And that way I only have one class called the segment class. But a better way to do it would be to say the road segment class inherits from the more general segment class. In other words, then I get all of these properties will be automatically part of the road segment class. And that way, if I go and say, for example, I start working on a rail network, a railway network, then I will have different properties. So there's nothing like rut depth on a rail network. There's not really texture depth, but you've got other properties to measure performance, like gauge, profile wear, twist, and things like that. So you can see here I've got two examples where I inherit from my segment class. So I get all of these properties will be available in here, provided they are marked as public or protected, right? Then I can have access to them in each of these classes. And you can see how I'm extending my code, and I can reuse the code in this class automatically in each of these two classes. Another use of inheritance in object-oriented programming is what's called overriding. So let's say, for example, you are creating a class to read data from a file. So you've got a file that you've got a class that you call the file reader class. And let's say that it's got some properties like what is the file name that you're reading from. You've got a property that says, does this file exist? You've got maybe a list of parse errors. And then you've got one method, I've marked it here in green, that says read from file. Now, at this stage, there's nothing here which says what type of file it is. It may be a XML file, it may be a JSON file, maybe just a comma delimited text file, or an Excel file, right? And so if I want to make this file reader class general enough, I'm going to have to add a method for each one of those different types of files. But a better way of doing that is to write a separate class specifically for text file reading. And then I inherit from this class and I simply override this method. So this method here, I will override in this class. And I will show you shortly what the syntax is of doing that in C#. And similarly, you can have an Excel file reader class, which also inherits from file reader, and it also overrides the read from file class. So these are the two ways that you can use inheritance to encourage your code reuse in your code base. The first one is by extending the properties of the base class, and the second one is by overriding some of the methods in your base class. You can, of course, make a combination of both. But the principle is basically that you are designing a base class so that you can create variations of that class without having to repeat some of the code in each of the variation classes that you are creating. Let's look at how you would do this overriding example in actual code. So here I've got my class file reader. Now you see there's a new word here that we haven't encountered, abstract. It says this is an abstract class. Now what that means is that, remember we showed in some of the previous examples when you initialize an example of a class. For example, you would say road segment, my segment equals new road segment. Now that you're calling the constructor and you're constructing an instance of a road segment. Now, an abstract class means that you cannot actually go and create an instance of it. It only provides the framework. You have to inherit from it to make it actually something that you can initialize. I know that's quite a mouthful. I'll talk about this a bit more when we discuss the homework. For now, just accept that there is something called an abstract class. Now, this is a file reader class. You can see it's got a property file name. It's got a property, does the file exist? And it goes and looks, and it's a read-only property. And it's got a list of string objects that gives the parse errors. And then here you've got your constructor. It takes a file name as a value, and then it sets the property file name. And then you've got a method, and this method is also abstract. In other words, you cannot call it in this class. You have to override it. And this method is called readData. So here is what an inherited class that is a text file reader. You can see the colon there. It inherits from file reader. And this method is going to inherit from file reader. And you can see I am overriding the readData method. In other words, I'm saying when you create this class text file reader, you can use all of these properties, but this method I want to override. I want you to do what's actually in here. And you can see there's all sorts of things in here. Just to basically give you an example of how you would parse the file. Let's not worry for now about the actual details. Here's another example where we now have an Excel file reader. Again, we're overriding the readData method, and here is where the actual code would go to parse data or read data from an Excel file. So those are two methods that you can use with inheritance to make you better use of your code, so that you don't have to violate the dry or do not repeat yourself principle. Now, when you are working with inheritance in practice, it is a very elegant way of writing your code. And I have found, especially when you're starting on a project and you're thinking about how you are going to put the classes together, how you will write your code, it's quite easy for you to get a type of a analysis paralysis, right? And I want to caution you to be careful of not over designing your code using all these inheritance principles too easy. The best thing is to simply just keep it simple. Write the code the way it's easiest for you to grasp it. So start by just creating the classes as you need it. And then when you see potential for code reuse through using these inheritance, then you refactor your code. So the moment you realize, I need a different class, but this class looks like it looks very similar to the one I've just written or the one that I've been using, but I just need to add a few more methods. Then don't copy and paste that class, just inherit from it, right? Or maybe you realize this class is exactly the same, but this method must work a little bit different for this application. Then you also inherit, but you override that method that you want to replace with a different implementation. So that's the way that I recommend you approach inheritance. The mantra is actually, whenever you see a potential to reuse code by changing your code structure, that's generally called refactoring. So refactor as soon as you see the potential and do that refactoring often. Okay, some homework. I've thrown in there the concept of an abstract class, and I know that is quite a bit of a stretch. I didn't explain it in too much detail. So for homework, I want to ask you to just go and ask ChatGPT using C# to explain the differences between an abstract class and a non-abstract class. Explain in concept before showing code. So if you can do that, then I think you will have the basic understanding already in your mind. When you actually get to the point when you're implementing this, you can go and explore it further, but at least you will be familiar with it. So that's it for this video. I'll see you in the next one. Thanks for watching.